Chapter 3, Section 2, Changes of State. Phase changes shouldn't be anything new. We know that when we change the state, it's also called a phase change, and it's just converting a substance from one phase to another. So we could be going from a solid to a gas, a liquid to a solid, a gas to a liquid, or back the other way. The identity of the substance does not change, but the amount of energy does. The law of conservation of mass just tells us that mass cannot be created or destroyed. It's conserved for all physical and chemical changes. The law of conservation of energy tells us that energy cannot be created or destroyed. Energy can change forms during physical or chemical changes, but the total amount present before and after is the same. So what you start with is what you end with. If energy of a substance changes, it is because it came from another source. Phase changes occur when we add energy in the form of heat, and it causes particles to move faster. For instance, if we start with the solid cube of ice, we add some energy to it, it becomes a liquid. We add even more energy to it, it becomes a gas or the water vapor. Removing energy causes those particles to move slower, and as they slow down, they start to clump together. So we go from a gas to a liquid to a solid. Some phase changes require energy, such as melting, evaporation, or sublimation. Some phase changes release energy, such as boiling, condensation, or deposition. A change in energy often means that a change in temperature has also occurred. Melting, moving from a solid to a liquid. The melting point is just the temperature at which a substance changes from a solid to a liquid. The melting point also depends on the pressure of the environment that it's in. If you increase the pressure, it lowers the melting point. Evaporation is moving from a liquid to a gas. The boiling point is the temperature at which that liquid turns into the gaseous form. For example, when humans sweat, that's a liquid. The heat from the body or the surroundings will cause evaporation. As the sweat evaporates off the skin, it takes the heat with it. And that creates that cooling effect on the body. Sublimation is the movement from a solid straight to a gas. We see this with solid carbon dioxide or dry ice as it moves from the solid to the state of matter of gas. Ice cubes can go from ice to gas while still in the freezer. Condensation, we see this on a moist, warm day. If we have a cold glass of a drink, the condensation forms on the outside of the glass. That moisture doesn't leak from the inside of the glass out. That moisture is the moisture from the air surrounding it. As it gets close to the cold glass container, it will cause those water droplets to condense and then deposit. So condensation is just moving from gas to liquid. The condensation point is the temperature at which a gas becomes a liquid. Fog is caused by condensation. The water gas particles will clump together. Energy is released from the particles and their movement slows down. This is the basis for the formation of clouds in the sky and why cumulus clouds have flat bottoms. Freezing is moving from a liquid to a solid. The freezing point is the temperature at which a liquid becomes a solid. Now keep in mind that the freezing point is going to be the same temperature as the melting point. Phase changes can be shown in a graph. We see that when energy is released, water freezes and absorbs when ice is melting. Energy is released when water vapor condenses and is absorbed when water vaporizes. During a change of state, temperature is constant. The temperature won't begin to change until the phase change is complete. All of the solid has melted and all of the liquid has evaporated.